On the CMOS press, we have some sample parts sent by the customer that I'm bending a program that was already created that I already spent some time on. This program has 4 bends, and with each step I'm stepping on the foot pedal. There is an optional pedal that is hands-free. So I move the piece back, I step on the pedal and it moves the slide up, and then I will need to step on the pedal again to move the ram. And the ram moves back automatically because of the mode that I have the program in. There's 3 different modes. You can do step by step, semi-auto, and full auto. And when you're using the side support, you're basically limited to a semi-auto mode, where the most automation it will do is retracting the ram back automatically. So here I step on the pedal, it moves the slide. I'll step on the pedal again, and the ram comes in and it will retract automatically. That's about as close to auto as you can get when you use the side support to move the distance. If you don't use that side support, you can step on that pedal one time and that ram will go back and forth as many steps automatically as necessary. Now there's the piece. The angles were a little bit large, not quite tight enough. And then within a program like that, the corrections can be made, and we'll display that at the end of this video. Here we turn on the machine and we have to calibrate the X and Y axis. You press start and it will calibrate the Y all the way up to 0. Now to calibrate the X, we have to move the ram all the way back and then hit enter to confirm the distance on the ram. Now we're going to go into manual mode to move the Y-axis all the way back out of the way so it doesn't impede our parts when we do some testing. Now we have that out of the way, we're going to go back into make sure we're in the bending mode. This has 3 different modes. We're going to be in the bending for the angle control. You can see on our first punch and die, and then our second one is blank. We're going to go ahead and create the same punch and die we had on the first one, but go through the process. You choose a name for the punch and then a name for the die. And then right there we have the punch radius, which is actually 5/8 of an inch. I put 1/2 an inch in just for the quick testing I was going through, but it is 5/8 of an inch. Now we put the calibration block in there, which is 0.984 inches thick. We bring the ram all the way up to the block, and we tell the machine that that is where that 0 point will be. And we hold F3 until it says on the bottom punch stroke value. That is confirming the calibration block and the value. Now we put in the material thickness, 1/2 an inch. Now F1 and F2 are the calibration bends, where the machine has its starting point when you go to programming your angle. Because when you're in the bending mode, you can do this setup, basically a profile setup. So for all your following programs that need to be created with different angles, with the same thickness of the material and the same width material, you can put in different angles and it will automatically calculate, get you close. You may have to input some corrections, but we're going to go ahead and the first bend needs to be a large bend and your second bend needs to be tighter. Now right here you saw that I made the bend and I'm checking my angle. But there's one step that I missed, and you'll see me catch myself once I'm done measuring the angle. But I'm shooting for about 145 to 150 degree angle. That's what I'm shooting for, because that's the drawing that we're going off of right now. Then right here I realized what I did. I had to put the material back in, and this is how the process is supposed to be. The material is in there, the ram comes in, you make your test bend, whatever you want it to be, you make that bend, and then you have to hold F1 so the machine remembers that position. It memorizes it. And then you back the material out. You check your angle. And then you have to tell the machine what that angle is. And I was right on 150 with that angle. Now our second bend needs to be tighter than 150. So we're going to go a little bit further. and I did it again. I did not memorize the position when I had the ram in there, so I'm going to go back in, put more pressure on that piece of material, bend it a little bit more, and then I will hold F2 so it can memorize that position. Now I pull the piece out, check my angle to see what it is, and then I will enter that into the machine so it will memorize that position. Now with this punch and die setup, when you're doing the profile setup like this, there is no saving. Once you enter the information, it's there. So the only way you can erase it is if you go in and physically input 0 for all the values. You see I didn't go through any save process. It is there. Now we're going to go into program. We're going to go to program 6. Program 6 is completely blank. The QT difference for X is where you want X, that RAM, to return between each step. I wanted it to return to 4.5 inches. So I put 4.5 in there. Now we're actually on step 1. Now I put the piece of test material in there. And this is a process that I had to go through in calculating my distances, because the customer's drawing only had a distance to the first bend and a distance for the last bend to the last leg, and the distance from the center to the second and third bend. So I go ahead and mark the first bend, and then I mark the last bend where it is, because it's a symmetrical part. Then I go to the center. I mark the center of the material, and I go both ways, because I did have the distance right there in the middle between the second and third bend. We had to use an AutoCAD program to calculate the angle of each of these bends because they were not on the drawing. Because the angle was one thing that we needed to know. Now right here you see me marking the distance of each bend. This is a 5/8 of an inch radius punch. So when we're doing a 90-degree bend, because you could do maximum 90 degrees, or minimum 90 degrees rather, the distance on that 90 degrees is 0.98 inches. So that's the distance of the bend. So once you figure out your angle of each bend, you can calculate the distance of each bend. About a 120-degree bend is roughly 3/8 of an inch on bend distance. So that way, you can move the part up to the punch and get it right in the middle. You can center your bend up instead of catching the edge of the bend, because the customer's drawings went to the edge of the first bend, and I had to calculate the center of the bend to get an accurate part. Now here you see me going through the lines. I'm entering in the distance of the punch. I'm entering in the angle. You can see me step 2 is a 150-degree angle, and I'm entering the distance value of Y where it feeds the material into the right position. Step 3 is also 150. Now all these numbers, I've already run this program a few times. I've already written down my numbers, so I already know what they are. Now our first and last bends are 120 degrees. Now the R at the bottom right is a repeat. I want these steps to repeat one time, or to run only once. They're not actually not going to repeat at all. They're only going to run one time. Now you hold the stop button for 3 seconds and the program will save. Now we're going to move into the automatic mode. You can see everything right there on the screen. One thing you have to do in automatic mode is put the thickness of your piece. You have to put that back in there, and that is not part of that is not saved in the program setup. It's saved in the automatic mode, and that will always stay there. If you back out and redo the automatic mode, it will still be there. The thickness of the piece will be there listed for that program. Now we're already hitting step 1, 120 degrees. Again, this is the part where I'm stepping on the pedal for each step of the process. I step on the pedal for the feed, and I step on the pedal for the ram to come in. And for this, I have also stepping on the pedal to retract it back. You saw the little bit of pause there between the retract. I'm stepping on the pedal for that as well. Sometimes if you're doing your test pieces and you're in manual mode and you feel that you did not bend it far enough, you can exit the program, go to manual mode, put a little more pressure on it, then come back out and go back into your automatic mode. In automatic mode, you can start from any step. You don't have to start from step 1. You can start from step 2 or step 3. Now here we're going to go and make some corrections. Right now I'm stopping the program again. We're on step 4. We're going to the correction side because the angle bends on the piece are a little tight. I'm going to go ahead and hit 3, then the minus sign, then enter. You can see where I entered -3. I'm going to put 0 back in there because step 4 is not where we want to make the correction. We want to make our way to step 2. Step 2 and step 3 are a little bit tight. The width on the part is very, very close. It's just a little bit tall, and the legs come a little too far in. So on step 2 and 3, we're going to put a -3 degree correction. That is degrees in correction. And that will spread the bottom legs out a little bit and bring the top down just enough. We're about 1/4 of an inch too tall on that. So you want to enter those corrections on step 2 and 3, which are bends 2 and 3. And you can see step 1 is 0. We're not going to make any corrections there. You can go to step 2 very easily. Select step 1 right there at the top. You can choose your step, make the corrections you need to make, and then bend your next part.